Hey, this is Metric Measurement Part 1. Here are the objectives. Identify how we can measure matter in metrics. What metric units do we use for length, mass, and volume, and how can we convert from one unit to another in the metric system? And remember that we are using the metric system in the science lab. Inches, feet, yards, dirty words in the science. The base unit for measuring length, which can also include width and height, is the meter. And of course, a meter stick we have and we use in the science lab, and here's a closer look at our meter stick. It has 100 centimeters, okay, and those are these guys right here, and it has 1,000 millimeters in a meter stick. Okay, and we'll take a closer look at what those prefixes mean in just a minute. The base unit for measuring mass is the gram. So here's 1 gram of gold, and to scale, you can see that it's next to a dime there. Of course, in the lab, we use our triple beam balance to measure for grams, and our base unit for measuring volume is the liter. And volume, remember, is the amount of space something takes up, and we typically are measuring for liquid volume, but that's certainly, liquids are not the only thing that takes up space. But here's an example of something we could use to measure volume. Here's a Nalgene bottle, but of course, if we want to be precise in the lab, we would use a graduated cylinder to measure for liquid volume. Volume is just the amount of space something takes up. So let's take a closer look at some of the prefixes that we can use when measuring for mass, for instance. Here's some of the prefixes and some of the units that we use for mass. Kilogram, okay? Kilogram is 1,000 grams. Kilo stands for 1,000. Here's our abbreviation, and a good comparison to kind of help you conceptualize it is 1 kilogram is the mass of a cantaloupe. I've also got a 1 kilogram mass here. It's about 2.2 pounds. Here's 1 kilogram about, okay, of maple syrup. And again, just to give you an idea or let you think about it, both of these are 1 kilogram. Which one has greater volume? Okay, think about that. Talk about it. And then, of course, the gram, and to help you conceptualize that, about the mass of 1 raisin is a gram. Okay, and there's our unit for gram. Okay. How about for length? We've got a few more here in length, and we just looked at a couple of these. A meter is our base unit. A meter is about the height of a door, or the height from the floor to a door handle. That's kind of cool fact that every door handle is just about exactly 1 meter high off the ground. So that's our base unit. 1,000 meters is a kilometer, okay? And a kilometer, or a kilometer, as you probably hear it called most of the time, is 0.62 miles. So some of you runners that know, if you run 5Ks, 10Ks, 1 kilometer is less than a mile. It's 0.62 miles, 1 kilometer. Okay, so there are 1,000 meters in a kilometer. Going smaller, we just looked at a centimeter. There's 100 centimeters in a meter, and 1,000 millimeters in a meter. Okay, and here's some things to help you conceptualize those distances. How about volume? Just a couple for volume. Here's our base unit, a liter, and again, it's about the space inside a Nalgene bottle. Another very common unit that we use in the lab is a milliliter. Okay, we measure in our graduated cylinders in milliliters, and 1 milliliter is about half a dropper or half a pipette filled with a liquid. And here's our units for milliliter, small m, capital L. Okay, so overview here. I want you to copy this down in your journal. A milliliter, where would that go? Well, it's volume, and it's the units that we use in the lab, because remember I just talked about that's what our graduated cylinders are labeled as. We use milliliters for graduated cylinders. How much space matter takes up? Well, that's our definition for volume, right? Centimeter, where would that go? It's definitely a length, but it's not a base unit. It's the unit we use often in the lab. Triple beam balance. I bet you recognize that as our equipment that we use for measuring mass. Meter stick or ruler. That's what we're going to use for measuring length, not a yardstick. Amount of matter in an object. Where's that going to go? That's our definition for mass. Graduated cylinder. That's our piece of equipment that we use for volume. distance between 2 points. We haven't really formally defined that, but I bet you can narrow it down to length. Okay, and remember that distance between 2 points can also be the height or the width of something as well. Okay, but both of those are used. We use length for both of those definitions as well. And then grams and kilograms. Well, they can't both be base units, so I can tell you that these are units that we use in the lab. We use both grams and kilograms. And then grams, that's our base unit for mass. Meters, that's our base unit for length. And liters, that's our base unit for volume. Okay, King Henry slider. Now, you're going to have a copy of this in your journal, and you use this to convert from one unit to another. It's so easy. So our metric system is based on units of 10, so all we have to do is move a decimal point. So if we start off with, and by the way, King Henry died unexpectedly drinking chocolate milk. Okay, these asterisks, these are real units, but we just don't use them, so we just start them out, so you don't have to get confused with some kind of complicated other metric system units that we really don't use, like the hectometer or the decameter. But we do use kilometer. Okay, so if you wanted to convert from a kilometer to a meter, you're going to move your decimal point 1, 2, 3 places to the right. Okay, if you're going to convert from a millimeter to a meter, you're going to move your decimal point 1, 2, 3 places to the left. So here's our rule. If you're going from larger to smaller units, move your decimal to the right. If you're moving from smaller to larger units, move to the left. Well, what does that mean? Let's take a look at one here. So if you wanted to convert 90 grams into kilograms, well, 90 grams are smaller than kilograms. That's a smaller unit to a larger unit. So here's our 90. Okay, and where would our decimal point be? We're going to have to add it here to the end, and we'll add a 0. So here's our decimal point now. We're going to go from grams right here to kilograms right here. So that's 1, 2, 3. So we've got to move this decimal point 1, 2, 3. So decimal point's going to go here. But we've got to also add a 0 here for place value. That makes a big difference. And we can get rid of this. That's not significant. That's not significant. Of course, we don't want to see where we moved our decimal point. But we do want to see the decimal point, so let me bring that back. Okay, so here's our answer. And we will put a 0 here in front of the decimal point to indicate that it's not a whole number. So 90 grams is equal to 0.09 kilograms. Okay. Copy these down. I want you to do the rest of these, and we're going to go over these in class. You can pause in class, but I do want you to copy this down, and I'm gonna look for this in class. So this is your homework. Copy these problems down and make these conversions, and I'm going to check this in class. Also copy these down. Circle the one concept that does not belong to each group. Let's do the first one together. What does not belong is grams. Okay, because grams is the only one that's a unit there. Okay, so circle the one that doesn't belong. This is for homework as well, and then you're going to have to justify why you chose the term that you circled.